Good morning. My name is Dr. Renu Pawels, Professor in Civil Engineering Department, School of Engineering, Cochin University of Science and Technology. My topic of research on biotrying process, a sustainable technology for municipal solid waste with high moisture content. My research objective is to develop a competitive and well acclimatized pilot scale biotrying reactor unit for treating the mixed municipal solid waste of high moisture content. The secondary objectives are to study the characteristics of the municipal solid waste based on proximate analysis, to investigate the technical feasibility of the biotrying process in the innovative biotrying reactor by continuous monitoring of the operational parameters and further design modification, to conduct experimental investigation to achieve the optimum biotrying process efficiency by promoting controlled aerobic reaction inside the reactor matrix with respect to specific airflow variation, to conduct detailed temperature profile analysis. Typical municipal solid waste characteristics are shown in this figure. Major component is organic 70 to 80%, textile is 7 to 10%, paper is 10 to 11%, plastic 7 to 9, inert is 2 to 4%. Municipal solid statistics in India is shown here. 0.45 kilogram solid waste is generated per capita per day. Urban municipal solid waste generated is 1,27,485 metric ton per day. There are some direct issues while disposing solid waste in the neighborhood area. First is mostly the solid waste is disposal in open dumps. It causes some public noisiness to the people. Also, the solid waste generally burn without proper measurement. It also pollute the natural water resources. There are some gaps in conventional treatment method. First is heterogeneous nature of municipal solid waste that leads to compost quality deterioration, anaerobic reactor failures. Waste segregation is an essential requirement. Municipal solid waste is not secured, separated or sorted. Recyclables are removed by waste pickers prior to the collection. Even the most stringent collection method cannot avoid mixed nature of municipal solid waste. Long duration of conventional method cause overloading of the treatment plant and increased space requirement, increased cost of storage and prevention, overloading of treatment plant, etc. Existing method of mixed municipal solid waste management are shown here. First is mass burn combustion, incineration, gasification and pyrolysis working on this principle. Then second option is RDA production and combustion. Last option is landfilling. The major hindrance in waste to energy applications are shown in this figure. Reduction of net energy value, difficulty in ignition, supplementary fuel requirement is required, unsteady and unstable combustion flame, increased formation of air pollutants, decrease in effective bulk density, increasing storage and transport cost, etc. Biotrying is a convective evaporation process. It effectively utilizes the biological self-heating reaction. It partially stabilizes the organic matter. It reduces the weight and moisture content and volume, but it increases the bulk density and also it increases the caloric value of the substrate. The methodology used in this research are shown here. The characterization study of the municipal solid waste has been carried out in the first stage to check the feasibility of the same for biotrying reaction. The proximate analysis of the different components of the mixed municipal solid waste substrate can be used to evaluate the moisture content and volatile solids content. In the second stage, an innovative pilot-scale biotrying reactor has been structurally developed for treating mixed municipal solid waste substrate of high moisture content. In the third stage, the biotrying process design has also been carried out to achieve controlled aerobic process inside the mixed municipal solid waste substrate so as to attain optimal self-heating reaction. The instrumentation design has been done by considering the critical process condition. In the fourth stage, the biotrying process in the pilot scale system has been monitored to assess the efficiency of the design system. In this stage, the research incorporates experimental investigation on the design system for delineating the mechanism of biotrying reaction through the continuous monitoring of weight loss, temperature profile, moisture content, and the volume reduction of reactor metrics. Different components of mixed municipal solid waste considered in the current investigation are organic, paper and cardboard, plastic, textile, etc. The result of proximate analysis are shown here. Uh, the average moisture content is 61% and average volatile solid content is 90.2%. Next is structural design of pilot scale biotrying reactor unit. The reactor design consists of an inner acrylic reaction chamber of 0.6 meter diameter and 2 meter height with a capacity of treating 0.565 meter cube of waste in one batch. The bioreactor unit consists of three structural components. First one is a perforated bottom chamber for maintaining uniform supply of air throughout the reactor matrix. The second structural component is an acrylic chamber which hold the reactor matrix. A right removable top chamber of 40 centimeter height is the third structural component of biotrying unit which is attached at the top of the reactor for holding the exhaust gas. The entire reaction chamber was developed by an insulation chamber made up of fiber coated steel which minimized the heat losses through the side walls of the reactor. The air supply unit consists of an air compressor followed by a digital mass flow controller which assists in maintaining a constant rate of airflow through the chamber. The volumetric flow through the control was designed as 40 liter per minute as per the psychometric design. Temperature of the inlet air was measured by probe 1. The probes 7 and 8 were inserted at the top chamber and air outlet respectively to monitor the exhaust air temperature. After fitting the reactor top air tight and carbon dioxide analyzer and humidity probes were inserted on the top chamber. The load cell was provided to continuously monitor the weight loss from the reactor, which can be used to assess the moisture loss from the reactor. Temperature profile in the biotrying process has been recorded in every second through the data acquisition system. The continuous observation and monitoring of the instrument readings as well as the reactor process condition were carried out for a period of 33 days. The biotrying reaction reduced and almost stopped by 21 days. In order to assess the further process, the reaction continued for further 12 days. So, here it's shown different fabrication stage, acrylic chamber, bottom chamber and exhaust gas pipe fixed are shown in this figure. Then you can see temperature probe installed and carbon dioxide humidity analyzer installed are shown here. Air compressor, storage tank, and digital mass flow meter used are shown in this figure. So next is experimental investigation. The objective of the study to study the moisture removal efficiency in the design pilot scale bio-drying reactor under the design process parameters. The main input process parameters are shown here. The initial moisture content is 61.25%, volumetric airflow 40 liter per, weight of mixed municipal solid waste is 109 kilogram, specific airflow rate is 528, exhaust uh, air dilution is nil, relative humidity is 55. Municipal solid waste substrate composition is given. Organic is 70.5%, paper and cardboard 13.5%, textile 8.9%, plastic is 7.1%. Waste collection and storage, the pictures are shown here. The weight measurement, substrate preparation stage, substrate mixing, the reactor filling, etc. were shown in the slides. These are the different views of the bio-drying reactor. So next is coming to the result. So in this slide, firstly, the initial 6-hour variation of temperature along the height of that reactor was plotted against time. The graph clearly indicates that initial 6-hour period is very critical for bio-drying process. The probes at 60 centimeter and 90 centimeter distance from the air inlet have showed a sudden temperature rise of 10 degree centigrade in the initial 6-hour period. The second consideration in the temperature analysis was to study the profile formation in the first 10-day period of bio-drying reaction. The temperature probes above 90 centimeter have recorded temperature fall since the condensed water has dripping downwards into the reactor feed through the side walls. The rising trend of temperature continued for first 3 days in probes 3 and 4 placed at a distance of 60 centimeter and 90 centimeter respectively from the air inlet. Then it started a decreasing trend. The temperature in probe at a distance of 30 centimeter from air inlet maintained the increasing trend up to 60 days and maximum temperature observed was 48 degree centigrade in this probe. Finally, the temperature profile for a period of 33 days has been plotted along the reactor height. The two well-defined peaks of temperature rise were observed in this 33 days of observation. The first cycle of temperature rise lasted till the third day of the probes 3 and 4. The probe 2 has recorded temperature rise till the 6th day, and after that a falling trend of temperature has been observed till the 15th day of the process. The falling trend of the temperature has resulted due to active bio-drying process and the resulting evaporative cooling. The second cycle of temperature profile has started on the probes 2 and 3 after 16 day of process at a rate of 5 degree centigrade to 10 degree rise per day. The rising trend continued only for a short duration of 1 day, and after that the temperature profile has shown falling trend. So next is the temperature contour map is shown here. The temperature contour for entire bio-drying process monitoring has been plotted in Origin Pro 8 software as shown in figure. It is clearly evident from the temperature contour that maximum self-heating at a peak temperature of 59 degrees centigrade has existed in the core region of the reactor matrix at 15 centimeter to 18 centimeter height from the air inlet. Also, the peak temperature self-heating has been sustained for a duration of 4 days. This clearly indicates that initial period is critical for the bio-drying process, during which the maximum self-heating process has to be explored. The biotrain reactor is placed over the load cell, and then the weight reduction has been continuously monitored. That is shown in this figure. The weight loss is calculated in every second of time, and the data has been transmitted through the data acquisition system, and it is the reading taken on the monitor of the computer. The result were plotted versus time. The weight of the reactor matrix was reduced by 37 kg in the initial 20 days of bio-drying process. The cumulative weight loss achieved in the bio-drying process was 33.94%, which is less than the actual evaporation loss because of the high rate of condensation of evaporated water back into the reactor. The average value of moisture analysis result of 6 samples were plotted against time along with the standard deviation error bar here. Average moisture content of the mixed municipal solid waste substrate at the end of 33 days of experiment was observed to be 48.5%, which is a reduction of 20.81%. The initial moisture content was 61.25%. The main cause of non-homogeneous moisture distribution inside the bio-drying reactor was the condensation of evaporated water back into the top of the reactor matrix. So next, the volume reduction graph is shown here. The volume has been reduced from the initial value of 0.39 meter cube to final value of 0.169 meter cube in 33 days of bio-drying process. It is a reduction of 56.5% volume in 33 days of bio-drying reaction. So next, bulk density profile is shown here. Bulk density showing a decreasing trend in the period from 10 to 20 days, and after that it started increasing again. The major increase in bulk density was achieved in the initial 10 days of the reaction itself. The monitoring of the bio-drying process has been carried out for 33 days, and the bulk density has increased by 52% at the end of 33 days of reaction. Some fly larvae and rotifers are grown inside the reactor. The pictures are shown here. The main process parameters, input and output, was shown here. The weight 33.9 for reduction after the end of 33 days. Average moisture content reduction is 20.81 percentage. Volume decreased by 56.5%. Bulk density in kilogram per meter cube increased by 52%. Maximum temperature obtained in the matrix in degree centigrade is 30 degree centigrade. So this is the figure of dried output taken from the bio-drying reactor. So next is summary and conclusion. The characterization study has revealed that the typical municipal solid waste of study area has an average moisture content of 61% and volatile solid content of 90.2%. It indicates that municipal solid substrate selected for the present investigation is having optimum condition for active bio-drying reaction. The first phase of the study has facilitated active biotrying reaction at the bottom region of the reactor matrix and biodegradation reaction at the top region of the reactor matrix. It was due to the condensation of evaporated water back into the reactor top region. The experimental demonstration of the innovative pilot scale biotrying reactor has yielded a cumulative weight reduction of 33.94% in 33 days of reaction. The moisture reduction was 20.81% in 33 days of biotrying reaction. Bulk volume reduction of 56.5% along with the bulk density augmentation of 52% was the major accomplishment in this investigation. Peak temperature of 55 degrees centigrade was obtained in the reactor matrix in the region of 50 centimeter to 80 centimeter height from the air inlet at the end of 3 to 4 days of reaction due to the self-heating of substrate. High temperature in the range of 50 degrees centigrade to 59 degrees centigrade have ensured the sanitation of the process output. Leachate production was completely eliminated in the upflow mode of aeration adopted in the innovative biotrying reactor. The biotried municipal waste in the suitable renewable solid waste is the suitable renewable fuel for incineration plant with the energy recovery in the form of heat and electricity, whereas the moisture-laden raw municipal solid waste needs auxiliary fuel for initiating combustion and hence unsuitable for energy producing application. Also, the biotried output can be directly used for energy production in gasifiers with the heat recovery. Thank you. The references are shown below.